Here we're going to work through another 6 examples of the laws of logarithms, and we're going to work through them without using a calculator. So it's just another way of showing that you know the laws and you don't need a calculator to be able to do the calculations, and the numbers are fairly easy to work with. So let's look at the first one, and we've got the log of 10,000 to base 10. Now with these, as is with the example here number 2, we'll try and make this into a base 10. And 10,000 as a base 10, it's quite easy. All you got to do is count the number of zeros. So 1, 2, 3, 4 is 10 to the power of 4. So if you had a million, for instance, there's 6 zeros in a million, so that's 10 to the power of 6. So instead of the number 10,000, we can write it. It's still the same. That's still 10,000. It's 10 to the power of 4. So we can write log to base 10 of 10 to the power of 4. And the reason we go to base 10 is that that's what the logarithm is to base 10. So that 4 by the third law of logarithms can come over the front here, and that's 4 log 10 to base 10. And the fourth law of logarithms is log a to base a is equal to 1, so log 10 to base 10 is 1, so that's 4 times 1, and that'll be equal to 4. We'll use a similar type of method here. We've got log to base 10 of 10 to some power, and we ask ourselves the question, 10 to what power is 0.001? So 0.001 is 1 over 1,000, which is 1 over 10 to the power of 3. And by our laws of indexes, 1 over 10 to the 3 is 10 to the minus 3. So all I have to do is put a negative 3 there. Same sort of method, we can bring the negative 3 at the front. And log 10 to base 10 is 1, so that's just equal to negative 3. This one here, we're adding logs. If we're adding logs, means we're multiplying the numbers. So that's the log to base 3 of 54 times a half. Now without a calculator, 54 times a half may seem a little bit difficult, but we can just go a half of 54. So there'll be log to base 3, and a half of 54 is the same as 54 times a half, and a half of 54 is 27. Once again, we need to probably express 27 as a base 3 because that's what our log is to the base. So log to base 3 of 3 to what power? Now 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27. 3 times 3 times 3 is 27. The 3 can come out the front. Log 3 to base 3 and log 3 to base 3, as you've seen from all these back here. Log 3 to base 3 is 1, so I won't write it there. The answer will be just 3. Here we're subtracting, so it looks like we're going to be dividing the numbers if we're subtracting logs. But we've got this 2 here, and we've got to actually move it before we can start, because we've got to have log minus log, not a number here. So that 2 we've already seen can go up as a power there. So we've got log 16 to base 5 minus log base 5 of 2 to the power of 2. Subtracting means we're dividing, so that's log to base 5 of 16 over, now 2 squared is 4. So that's log to base 5, 16 divided by 4 is 4. And that's as far as we need to go at this stage. We can't do that without a calculator, and there is a method to be able to work that out as a decimal, which we'll do a little bit later on. So that's as far as we can go, and we've simplified it. This one here, there's no rule for dividing logs. There is multiplying the numbers you add when you are dividing the numbers you subtract, but here we're dividing the logs. This is a number, this is a number, and we're dividing those. So there's no rule for that, but maybe we can do something up here and do some sort of simplification. So let's do, since we've got log to base 3, we've got log to base 3 both top and bottom, and we've got a 2. So we can reduce this to a base 2. So that'll be log to base 3 of 2 to what power? Well, that's 3. 2 to the power of 3 is 8, over log of 2 to base 3. Now that 3 can come out the front. So that's 3 log to the base 3 over log 2 to base 3. Now there's a multiply understood there. So if you like, we have got a similar entity here. We've got log of 2 to base 3, log of 2 to base 3. They will turn out to be numerically exactly the same value, so we can cancel those. We multiply out the tops. 3 times 1 is 3. Multiply out the bottom is just a 1. 3 over 1 is simply the number 3. Looks like we've got a lot of 3's in our answer here, but anyway. Okay, next one here, we are subtracting. So we're subtracting logs, we are dividing the numbers, but which ones do we do first? Well, we go to our BIDMAS. There's no brackets, there's no indexes, there's no division, no multiplication. These two are of the same priority, and we do addition or subtraction left to right. So we do the first addition or subtraction where we go left to right. We do a subtraction first. So we'll do this one first. So we do it in steps. So we've got this, we could put a bracket if we like around there to just remind ourselves to do that first, and then we'll just tag this at the end and we'll just keep working our way down. So when we're subtracting, we are dividing, so that's log to base 4 of 24 over 2 minus log 6 to base 4. So the minus tells we are the minus here tells we are dividing the numbers, so that's why we divide 24 by 2. 24 divided by 2 is 12, so that's log 12 to base 4 minus log 6 to base 4. And here we are subtracting the log, so we are dividing the numbers. So that's the log to base 4 of 2. And you can ask yourself, log to base 4, well, we've got 2 as a base is log to base 4 of 4 to the power of 0.5. 0.5 is a square root, and the square root of 4 is equal to 2. So 4 to the power of 0.5 is another way of writing the square root of 4, which is 2. But what it does, because we've got log to base 4, by making this base 4 here, we can bring the 0.5 to the front. We know that that is equal to 1, so the answer is 0.5. Another way of writing, obviously, you might have worked in fractions, it would be equal to a half. Okay, so getting to there was fairly straightforward by just doing BIDMAS and working left to right, but a little bit of intuition coming from there down. 4 we know is 4 to the 0.5, because to the 0.5 or to the half power is the square root of 4, which is 2. And then that allowed us to do log 4 to base 4, which is 1, and then the 0.5.